Hey guys, so what I'm going to talk about is polynomial inequalities, okay? There are two ways we can solve polynomial inequalities, my apologies. But first, you need to understand what the question's asking, okay? When we look at this question, it says x minus 4 times x plus 2 is greater than 0. So what it's saying is, what are x values that make your output, that means after you plug them in, greater than 0. So basically saying, what are the x values that make y greater than 0? What does it mean to be greater than 0? It means to be positive. Okay? So that's what the question's asking. It's asking, what are x values that make y positive? Okay? There's two ways to approach this. There's a graphing way, and there's an algebraic way. I'm going to show you the graphing way, but we don't have our graphing calculators right now, so you're really going to want to focus on the algebra way. Okay? Plus, the algebra way is just way cooler. All right, so the graphing way. First, what you want to do is just graph. Okay, so we have our graph right here. This is our graph of x minus 4 times x plus 2. Okay. Now, the next thing you want to think about is, what does it mean graphically for y to be positive? That's right. It means that I'm above the x-axis. Y is positive as long as I'm above the x-axis. Okay? So I'm above the x-axis all right here. So then we know the answer is this portion and this portion. I have to ignore this portion. So how do I do that? How do I write that these are my answers? How do I write down that this is a set of x values that works? Well, first, it's important to realize that till more left I go, I just keep going on forever to the left, and y just gets more and more positive. So that means that all the x values to the left are good. So what does that mean? Negative infinity. And it's negative infinity all the way to what x value? Negative 2. So we're saying negative infinity to negative 2, those x values are good. Those x values give you positive y values. Negative infinity to negative 2. And then there was that second interval, right? There was that second set. That was from 4, and it kept going, right? Y just continues to be positive, 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 positive on for eternity. So from 4 to infinity. That's right. From 4 to infinity. It's just that easy on the graphing way. It really is. But to me, it's boring easy, okay? So I'm going to show you guys a really cool algebraic approach. Okay, so first, let's look at the graph one more time. What do you realize really mattered? The x-intercepts, right? What's another word for x-intercepts? Zeros, okay? So to do the algebra way, the first thing you have to get is your zeros. So you write down your zeros, which in this case, for this problem, we would set both of these equal to 0, and we would get 4 and negative 2. Then what you do is you make yourself a number line, okay? My number line is super straight. So negative 2 and 4. And what you do with this number line is you pick x values that are to the left, such as negative 3, that are in between, such as 0, and that are to the right, such as 5. And you're going to plug them in, and you're just going to see if y is either positive or y is negative, okay? It's one or the other, all right? Either if y is positive, then we know that interval of x values is true. Because why does this work? Let's talk about why this works real fast. Where is the only place that y can change from being a positive to a negative or from being a negative to a positive? That's right, the x-axis, right? Only time y changes from being positive to negative is when I cross the x-axis. So that's why these zeros matter, because I know that the only time that y could change from being negative to positive is either here at negative 2 or at 4. So that means no matter how far more to the left I go, y is going to stay the same sign. Now I don't know what that sign is at the moment, but it's going to stay the same sign. I know that when y is between negative 2 and 4, it's going to stay the same sign. Once again, I don't know what that sign is at the moment. I'm going to find it, but I know it's going to stay the same sign. And then I know that when y is greater than 4, it's going to stay the same sign. And I'm going to figure out what that sign is. So first, realize that all we're asking there is about signs. So we don't actually care about the number we get when we plug in a negative 3. We just care about if it's going to be a positive y or a negative y. So we plug in negative 3. Plug in negative 3. That gives me some negative number, because negative 3 minus 4 is negative. Negative 3 plus 2 is negative. So that gives me some negative number times some negative number, which is a positive overall. We plug in 0 here and here. We would get negative 4 times 2, which is negative 8. It's negative. We plug in a 5. We get 5 minus 4, 5 plus 2. That's a positive times a positive, which is a positive. So once again, what's my goal here? My goal is for x values that make y to be greater than 0, which is positive. So that means I was positive in this interval and I was positive in this interval. So what are those two intervals? Well, negative infinity to negative 2, and then again from 4 to infinity, which is the same answer I got when I did graphing. Okay? Now, why am I using parentheses on the negative 2 and the 4? Because it's not equal to here, right? It was just greater than 0. It wasn't equal to. If it had been greater than or equal to, then the negative 2 and the 4 would get brackets. But since it did not have the equal to, it's just parentheses. Okay? So guys, I hope that explained everything. To do the algebra, you do have to find the zeros, which means on some of these problems, the first thing you're going to have to do is to factor. Okay? So make sure you think about that, especially when you get to problems like 5 through 8. Okay? All right, guys, let me know if you have any questions. Have a great day.